This is a number line. Look at it. Look at it. And if there's one thing that we know about number lines from years past is that number lines go on and 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 on forever. Infinity. And that is represented by arrows at the end, saying that they go on and on this way and on that way. The number line, along with this new addition, will be a little bit different today, but it's still not mind-blowing. We're going to go back. This is, just like those rectangles, one hole. So it starts with 0 here and 1 here. Very familiar to you. Going back to the candy bar references. We have one hole here, and we are going to split that into thirds. So each unit fraction would be 1/3, 1/3, and 1/3. If we were to label our number line, it would be, how many did I color in? 1/3. How many now? 2/3. And now I colored in the whole thing, or 3/3. If we will look at our fractions, our denominator is 3. It's always going to be something out of 3, because this candy bar, this particular one, only comes in 3s, because that is one whole candy bar. If I had a rectangle, wow, that took a lot to say, and I don't know why. If we had a rectangle, we would see that the rectangle started here and ended here. That is one whole rectangle. Today, we're going to go to the store and we're going to buy 2, 3, 4 candy bars. But we need to remember that our candy bar comes in thirds every time we buy one. So if we go to the store, we get 0 candy bars. We bought 1 candy bar and 2 candy bars. Remember that our number lines go infinity either way. Think, how many pieces was 1 candy bar broken into? Thirds. So this candy bar is going to be broken into thirds. And this candy bar is going to be broken into thirds. And then taken away and broken into a better third. So we have 2 candy bars here. One candy bar. What in the world is going on? 1 candy bar here. And 1 candy bar here. We have 2 candy bars. Just looking at this candy bar right here, it's broken into thirds, so I have 1/3, 2/3, and 1 whole. Just focusing on the words that I say. This candy bar is also broken up into what? Thirds. However, again, just focusing on the words that I say, I have 1 colored in for 1/3, 2 colored in for 2/3, 3 colored in for 3/3. how many do I have colored in now? 1, 2, 3, 4 thirds. How many now? 5 thirds. How many now? 1, 2, 3, 4, 5, 6 thirds. A few days ago we talked about how this is an improper fraction, which just means that I went over one whole, but they're still broken up into thirds. They don't make a candy bar that's not broken up into thirds. Now it depends on what your denominator is. Maybe they don't make a candy bar that's not broken up into sixths. Your denominator is determined by what is 0 to 1 whole. After that, it does not change. So look at 0 to 1 whole, broken up into thirds. So if we had a number line that was 0, 1, 2, 3, 1 whole is broken up into thirds. 1 whole, or 1 to 2, is broken up into thirds. And 2 to 3 is another third, or another whole, so it's broken up into thirds. We have 1 whole candy bar, 2 whole candy bars, and 3 whole candy bars. Each candy bar is broken up into thirds. We know that this is colored in 1/3, colored in 2/3, colored in 3/3, colored in 4/3, colored in 5/3, colored in 6/3, colored in 7/3, colored in 8/3, and colored in 9/3. So according to this, 2 candy bars equals 6/3. 3 candy bars equals 9/3. Whatever you have for a whole piece, in our situation it was 0 to 1, was the one that we're looking at. 0 to 1 was thirds. Before you start with your number lines, you need to figure out 0 to 1 whole. And everything after that is just counting. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. However, before you can start, you need to figure out what 1 whole is. Looking at 1 whole, that was broken up into thirds, which means that this whole candy bar doesn't change, and this whole candy bar doesn't change. They don't get bigger or longer. They just are thirds. So before you start to find your denominator, you need to find out what 0 to 1 is. And then the rest is just counting.